Welcome to the Depth Dive. Today, we're digging into something pretty fascinating. It's this intersection between a major scientific revolution and, well, a really influential philosophical system.
That's right. We're looking at James Clerk Maxwell's work on electromagnetism, truly groundbreaking stuff, and how it connects, maybe indirectly, with Alfred North Whitehead's process philosophy.
And we want to do this with a kind of college-level understanding in mind, really unpacking the idea. So we're drawing on a few key sources for you today.
Yeah, we've got excerpts from how James Clerk Maxwell's revolution rippled through Alfred North Whitehead's philosophical ocean, also Consciousness, Whitehead, and Maxwell's equations, and another one called Whitehead's electromagnetic societies.
Okay, so the mission here, our goal for you, is to explore how Maxwell's scientific earthquake, if you like, sent tremors through the philosophical landscape, influencing Whitehead, even though they weren't exactly, directly collaborating on philosophy.
It's a really interesting case of how big scientific ideas can sort of permeate the intellectual atmosphere and shape philosophical thinking in subtle ways.
Definitely. So let's start with Maxwell. Before he came along, what did the scientific world look like? What were people thinking?
Well, it was really dominated by Newtonian mechanics. Think of the universe as basically made of little separate bits, discrete particles.
Like tiny billiard balls.
Kinda, yeah. And forces between them acted instantly across empty space. Space itself was seen as passive, just a container.
An empty stage, basically.
Exactly. And crucially, electricity and magnetism were treated as completely separate things. Different forces, different laws.
Right. Totally unrelated phenomena.
That was the prevailing view. A universe of separate stuff with instantaneous pushes and pulls.
Okay. And then Maxwell steps in. What was his big move?
Maxwell's genius was synthesis. He took all the experimental work done by people like Faraday and Ampere on electricity and magnetism.
The hands-on guys.
Right. And he unified it all into a single coherent mathematical framework. His famous four equations.
Maxwell's equations, yeah. We've all heard of those.
But here's the kicker. They didn't just describe electricity and magnetism. They predicted something entirely new, the existence of electromagnetic waves.
Waves, like ripples.
Exactly. And this is the really stunning part. His equations predicted these waves would travel at the speed of light.
Whoa. So implying light itself was...
An electromagnetic phenomenon.
Yeah.
That was a radical idea.
That must have caused quite a stir.
Oh, absolutely.
Yeah.
And then a bit later, Heinrich Hertz actually experimentally detected these waves.
He found them.
He did, which was massive confirmation. It showed light wasn't separate. It was part of this unified electromagnetic picture. It fundamentally changed how we saw the universe.
But it wasn't just particles anymore.
Not just particles acting at a distance. Suddenly you have this idea of fields, invisible fields, filling space, carrying energy, propagating waves. It's a move from, like you said, billiard balls to interconnected vibrating fields. A huge paradigm shift.
Okay, so what were the big intellectual takeaways, the main ripples from this Maxwell revolution?
Well, there were several major ones. First, and maybe most fundamentally, was the rise of field theory.
Right, the fields you just mentioned.
Exactly. This idea that the field itself permeating space was a fundamental entity. It replaced the old action at a distance idea. Forces weren't instant magic jumps across space anymore. They were mediated by the field.
So space wasn't empty or passive anymore.
Precisely. It became an active participant. That's a huge shift in thinking about reality itself.
Deliberately. What else?
Second, it really highlighted the interconnectedness of phenomena. Unifying electricity, magnetism, and light showed there was a deeper unity in nature than people thought.
Things weren't as separate as they seemed.
Right. It suggested that different aspects of reality were just different manifestations of some underlying shared structure, a hint of deeper cosmic coherence.
And the way he did it using math, that was important too, wasn't it?
Absolutely. Third point, the power of mathematical abstraction. Maxwell's theory is deeply mathematical. These abstract equations had incredible predictive power.
They predicted things nobody had seen yet.
Exactly. It showed how powerful abstract mathematical thinking could be in uncovering truths about the physical world, truths not obvious from just looking around.
And you mentioned waves and energy, so a more dynamic picture.
Yes. Fourthly, Maxwell painted a picture of a dynamic and energetic universe. These electromagnetic fields weren't static. They carried energy, they carried momentum, they propagated as waves.
Not like a fixed clockwork machine.
Not at all. It was a universe inherently full of activity, energy flow, constant change, a stark contrast to the older, more static mechanical view.
Okay. Now, there was this other thing tangled up with light waves back then, The ether.
Ah, yes, the luminiferous ether. Fifth point. Initially, Maxwell himself and most physicists assumed these waves needed something to wave in, like sound waves need air.
So they proposed this invisible ether filling all of space.
Right. But the problem was, try as they might, experiments kept failing to detect it. The most famous was the Michelson-Morley experiment.
And they found nothing.
Nothing. No evidence of this ether. And this failure, this experimental dead end, was actually incredibly important
How so?
because it forced a major rethink. If there's no ether, how do light waves travel? This puzzle eventually paved the way for Einstein and his theory of special relativity.
Wow. So the failure to find something led to another revolution.
In a way, yes. It showed the old framework, even with Maxwell's updates, wasn't quite right. It challenged fundamental assumptions about space and time.
Okay, a truly massive shift in physics. Let's pivot now to Alfred North Whitehead. Who was this guy?
Whitehead is fascinating. He started out as a top-tier mathematician. He even co-wrote Principia Mathematica with Bertrand Russell, a landmark work in logic and math.
Right, a serious mathematician.
Absolutely. But then later in his career, he made this remarkable shift into philosophy. He developed a whole metaphysical system called process philosophy.
Process philosophy, what's the core idea there?
The absolute core is rejecting what philosophers call substance metaphysics, the idea that reality is made of enduring, independent things or substances.
Like the old particles idea in physics.
Sort of analogous, yeah. Instead, Whitehead said reality is fundamentally process. It's a dynamic flow. The basic building blocks aren't static things, but momentary events of experience he called actual occasions.
Actual occasions, like little bursts of experience.
Exactly. Fleeting, momentary events. These are the ultimate real things for Whitehead. Reality isn't a collection of stuff. It's this ongoing flow of these experiential moments.
And are these moments isolated?
No, absolutely not.
Okay.
And this is crucial. They are intrinsically connected. Every actual occasion is influenced by and influences others through a process Whitehead called prehension.
Prehension, what's that?
Think of it like feeling or grasping or taking account of. Every moment of reality prehends the rest of reality, especially its immediate past. It incorporates the influence of other occasions into its own becoming.
So everything is interconnected through this feeling.
At a very fundamental level, yes. This intrinsic relatedness is key to his whole system.
Okay, so what are the main pillars of this process philosophy?
Well, first, as we said, the primacy of process. Reality is becoming, not static being. Everything is constantly emerging, developing.
Always in flux.
Always. Second, this idea of interconnectedness and internal relations. An actual occasion is what it is because of its relationships, how it prehends others. Its relations aren't external additions. They define its very essence.
That sounds quite different from thinking of things having independent properties.
It's a radical departure, yeah. Third, Whitehead expands the notion of experience. It's not just for humans or animals. For him, every actual occasion, down to the most basic physical event, involves some rudimentary form of feeling or prehending. It's kind of pan-experientialism, you might say.
Wow, okay. Experience everywhere.
At some level, yes. Fourth, there's creativity and novelty. The process isn't just a predetermined unfolding. There's a fundamental principle of creativity allowing for genuine newness, spontaneity in each moment of becoming.
So, not fully deterministic?
Not at all. And finally, he talks about eternal objects. These are like abstract possibilities. Think qualities like redness or roundness or mathematical forms. They don't exist in time and space themselves, but they provide the potential forms or patterns that actual occasions can realize. They ingress into occasions, giving them definite character.
Abstract potentials becoming concrete.
Something like that, yes, providing the what for the how of becoming.
Now, you mentioned Whitehead was a mathematician. Did he actually engage with Maxwell's math?
He absolutely did, and this is where the threads start to connect, even if indirectly later on. Get this.
Yeah.
Whitehead's doctoral dissertation back in 1884 was on the mathematics of Maxwell's equations.
No kidding. So he knew them inside out.
Deeply. He was apparently really captivated by their precision, how they mapped out electromagnetic energy moving through spacetime. And then for 24 years, he taught math and physics at Cambridge.
So he lived and breathed this stuff early on.
Definitely. There are even stories, perhaps anecdotal, that he was fascinated by Nikola Tesla's demonstrations of electromagnetic fields in London in the 1890s.
Wow. So it wasn't just abstract math for him.
It seems not. And this deep immersion in the electromagnetic worldview, shaped by Maxwell, clearly lingered. Consider this quote from his major philosophical work, Process and Reality. Our cosmic epoch is to be conceived primarily as a society of electromagnetic occasions.
Electromagnetic occasions.
Okay.
That's a striking phrase. What did he mean by that?
It's suggestive, isn't it? He used the term concrescence for the process where an actual occasion and one of those drops of experience comes into being. These are the fundamental real things, the quanta of experience.
And physical objects, like this table.
For Whitehead, things like tables are complex societies of these actual occasions, collections bound together by shared patterns, inheriting characteristics over time.
Okay, so where do the electromagnetic occasions fit in?
He argued that our particular cosmic epoch, the current state of the universe, is dominated by a specific type of society, an electromagnetic one. And the individual actual occasions making up this society are what he calls electromagnetic occasions.
So he's linking his basic metaphysical units to electromagnetism somehow.
He is. He even posits those eternal objects we mentioned outside space-time as providing the creative potential influencing these occasions. It strongly suggests he saw the principles Maxwell uncovered as fundamental to how reality operates, at least now in our epoch.
Right. So let's bring it together. Maxwell changes physics with fields and interconnectedness. Whitehead builds a philosophy around process and interconnectedness. Where's the resonance? Was Whitehead consciously applying Maxwell's ideas?
Not directly applying the equations in his philosophy, no. It's more like Maxwell's revolution changed the intellectual air everyone was breathing. The concepts resonated.
Okay, so what are the key points of resonance?
Well, first, there's that big shift from substance to field and process. Maxwell's fields challenged the primacy of discrete particles.
Yeah, things became continuous fields.
And Whitehead's process philosophy explicitly rejects enduring substances in favor of dynamic events. Both are moving away from static things towards dynamic, relational entities, fields for Maxwell, actual occasions for Whitehead. It's a huge parallel.
A move from noun thinking to verb thinking, almost.
That's a nice way to put it. Second, the primacy of relations and interconnectedness. Maxwell unified electricity and magnetism, showing deep connections. Whitehead makes internal relations, the prehensions between occasions, absolutely central to what things are.
So in both systems, relationships aren't secondary, they're fundamental.
Exactly. The way effects ripple through Maxwell's fields feels analogous to how Whitehead's occasions mutually influence each other through prehension. Everything is tied together.
And you mentioned energy and dynamism earlier for Maxwell.
Right. Third point, the dynamic and energetic nature of reality. Maxwell's fields carry energy. Things propagate. It's all active. Whitehead's philosophy is all about becoming, the inherent drive or aim within each occasion striving towards realization. There's an echo of that physical energy in Whitehead's metaphysical dynamism.
It's a universe buzzing with activity in both views.
Precisely. Fourth, given Whitehead's background, the role of abstraction and mathematical understanding is a clear link.
Even if he didn't use the equations directly later.
Yes, because Maxwell showed the sheer power of abstract math to grasp reality. Whitehead, the mathematician, deeply appreciated that. His philosophy, while metaphysical, carries that same respect for underlying structures and formal relationships, even if expressed differently. His training shaped his thinking.
Makes sense. What about determinism? Physics was pretty deterministic before, right?
Largely, yes, and that leads to a fifth point, challenging determinism and embracing novelty. The ether problem in physics, and what came after with relativity and quantum mechanics, started chipping away at strict determinism.
Things got weirder, less predictable.
Right. And Whitehead, quite explicitly, built creativity into a system. Each actual occasion has a degree of freedom, of novelty in how it becomes. So both physics, post-Maxwell's initial framework, and Whitehead's philosophy moved towards a less rigid, more open-ended view of reality.
Interesting. And finally, what about the basic stuff of reality?
Sixth point, the implicit ontology of fields and events. In physics, the field evolved from just being a mathematical tool to describe forces to being seen as a fundamental thing itself with energy and reality.
This field became real.
Kind of, yeah. And this resonates strongly with Whitehead's event ontology. For him, the momentary events, the actual occasions, are the primary reality, not enduring substances. Both views shift the foundation from static things to dynamic happenings or fields.
Okay, that maps out the conceptual resonances really well. You mentioned Whitehead talked about societies of actual occasions.
Yes, he defined a society as an ordered collection, a nexus of actual entities that share common characteristics passed down through prehensions, making them self-sustaining over time.
Like the society that makes up an electron or a rock.
Exactly. And he specifically said, our current special cosmic epoch is characterized by societies of electronic and protonic actual entities, the stuff of physics. And crucially, he says it's in this epoch that Maxwell's equations hold true.
So he's directly connecting his philosophical entities to the physical world governed by Maxwell's laws.
He is. Which leads to this really deep question the source material raises. Are these fundamental electronic and protonic patterns somehow inherent in every moment of human experience, in each concressing actual occasion?
Could the fabric of our subjective experience have an electromagnetic basis?
That's the provocative idea. Remember, he explicitly called our epoch's dominant reality an electromagnetic society made of electromagnetic occasions, linking it directly to the physical electromagnetic field.
So if we take that seriously, what about the electromagnetic spectrum itself? All those frequencies, from radio waves to gamma rays.
Well, the source material gets quite speculative here, suggesting maybe this spectrum, this vast range of energy frequencies, isn't just something physics describes, but could be the very arena where Whitehead's electromagnetic occasions live and interact.
The playing field for reality's basic moments.
Potentially, yes. And it then points to the mathematics that bridge different domains, specifically highlighting Euler's law.
Euler's law, I vaguely remember that from math class.
It's often called a remarkable formula because it elegantly connects trigonometry and complex exponentials, effectively linking the time domain and the frequency domain mathematically.
Okay, time and frequency, how does that relate?
Well, Euler's law is the foundation for something called the Fourier transform, and that is everywhere in modern technology.
Fourier transform, right? Used in, like, signal processing.
Exactly. It's a mathematical tool that lets you break down a complex signal over time, like your voice, into its constituent frequencies, and vice versa. Think about your cell phone. It uses Fourier transforms to convert your voice, a time signal, into frequency patterns for transmission, then back again.
Wow, that's built on Euler's math.
Fundamentally, yes. The text even mentions the Mandelbrot set, that incredibly complex fractal image, as a kind of visual representation of this boundary between time and frequency domains, describing it as having a profound and timeless reality discovered through math.
It's amazing how abstract math describes real-world processes.
It really is. And the text brings in Norbert Wiener, the founder of cybernetics.
Cybernetics, control systems, information theory.
Right. Wiener was fascinated by biology, too. He actually used the math derived from Euler and Fourier to analyze brainwaves, EEGs, trying to understand the frequency patterns of thought.
Analyzing the brain in terms of frequencies.
Yes. He even speculated, way ahead of his time, that biological systems might self-organize and communicate across different frequency bands, maybe even infrared or radar spectra. He imagined molecules potentially communicating via frequency pattern.
Molecular communication by frequency. That's wild.
It is speculative, but intriguing. Then the text mentions Joseph Chilton Pearce, who talked about the human heart generating a powerful electromagnetic field, a toroidal field, extending maybe 12, 15 feet around the body.
A heart field. Extending that far.
According to Pearce's work, yes. Which, again, prompts the question the text poses. Could Whitehead's concressing electromagnetic society of actual entities find some physical echo in this kind of complex human electrophysiology?
Is our own body's electromagnetic activity related to these fundamental occasions?
That's the connection being explored. The text even draws a parallel between technological microwave cavities, electromagnetic resonators, and the fluid-filled ventricular cavities inside the human skull.
The ventricles in the brain, as resonators.
It raises the possibility, highly speculative, of course, of some kind of natural energy frequency communication system within the brain using these cavities. It touches on an MIT physicist's model involving quantum coherence, Bose-Einstein condensates, interacting with the classical neuron system.
Blending quantum physics and neuroscience.
And potentially involving these resonant cavities. And then, perhaps most evocatively, it brings in a passage from Taoist yoga.
What does that say?
It describes an original cavity of spirit located right in the center of the brain, behind the eyes. This spot is linked to prenatal energy, vitality, and sometimes visualized as a tiny bright pearl.
A pearl of energy in the center of the head.
Yes. And the text connects this ancient description to the physical location of the brain's ventricles, suggesting this might be pointing towards a potential focal point of energy or consciousness, possibly related to these resonant electromagnetic ideas.
Fascinating convergence of physics, philosophy, biology, and even ancient traditions.
It's definitely weaving together many threads.
Okay, so let's try to synthesize this. After this whole deep dive, what's the main thing we should take away?
I think the key takeaway is how profoundly Maxwell's scientific revolution, shifting focus to fields, energy, interconnectedness, really changed the intellectual landscape. And this new landscape deeply resonated with and indirectly shaped Alfred North Whitehead's process philosophy.
Even though Whitehead didn't just translate Maxwell's equations into philosophy.
Right. His specific engagement with the math evolved, but the conceptual shift Maxwell triggered towards dynamism, relationality, away from static substances, finds this incredible parallel in Whitehead's metaphysics.
It really highlights how connected science and philosophy can be, sometimes in surprising ways, how big scientific ideas ripple outwards.
Absolutely. It shows that our ways of understanding physical reality and our ways of thinking about fundamental existence are perhaps more intertwined than we sometimes realize.
So to wrap up, what's a final thought for you, our listener, to chew on?
Well, maybe consider this. Today, we understand the electromagnetic spectrum and information theory, building on Maxwell's foundations, in ways that were unimaginable back then. Could our modern understanding of electromagnetism, signals, and information actually give us new tools or perspectives to revisit Whitehead's idea of electromagnetic occasions?
Could current science shed new light on his philosophy? And perhaps even on the nature of consciousness itself?
Exactly. It's an open question sitting right there at that fascinating crossroads of physics, philosophy, information, and maybe even consciousness studies. Something to ponder.